Your aunt eats whatever she wants, never exercises, and is a size 4 at 62. Your colleague works out 5 days a week, meal preps on Sundays, hasn't touched a dessert since 2019, and cannot seem to lose the last 15 pounds no matter what she does. And you're somewhere in the middle, watching both of them and wondering if the whole thing is just a lottery you either won or lost at birth. Here's the question that has quietly broken more diets, derailed more fitness journeys, and caused more existential spirals than almost any other in health and wellness. Is your weight mostly genetics or mostly choice? And here's the honest answer that the fitness industry doesn't want to sell you, and the body positivity movement sometimes overcorrects around. It's both. Significantly both. In ways that are specific, measurable, and this is the part that actually matters, actionable once you understand them. Because the conversation is no longer nature versus nurture. In 2026, we have enough genomic data, epigenetic research, and microbiome science to have a genuinely sophisticated answer. And that answer changes everything about how you approach your own body. Not more discipline, not less self-acceptance, just a much more accurate map. Let's build it. What the genetics research actually says. Let's start with the science because the popular versions of this conversation, both "it's all genetics, nothing you do matters" and "genetics is just an excuse," are both wrong, and being wrong about this is expensive. The most comprehensive data we have comes from large-scale twin studies, research designs where identical twins, who share 100% of their DNA, and fraternal twins, who share roughly 50%, are compared across different environments. The findings are consistent and have held up across decades of replication. Heritability of body weight, approximately 40–70%. That number means that somewhere between 40 and 70% of the variation in body weight across the population is explained by genetic factors. The range exists because heritability varies by environment. In food-abundant, low-activity environments, modern developed world, genetic influences express more strongly because the environmental baseline is already high for everyone. In genuinely food-scarce environments, genetics matters less because the external constraint dominates. What does this mean practically? It means your genes set a range, not a fixed number. Researchers call this the settling point, or sometimes the set point range. Your genetics define a weight corridor of roughly 10–20 pounds within which your body will defend itself with extraordinary biochemical aggression. Trying to stay significantly below that range requires constant effort because your body will deploy every hormonal tool it has: elevated ghrelin, reduced leptin, lowered metabolic rate, increased hunger, to pull you back up. This is not weakness. This is homeostasis. Your body doing exactly what evolution designed it to do. But here's what people miss: that range is not fixed for life. It is influenced by environment, by behavior, by what you feed your microbiome, by how you sleep, by your stress load, and critically, by epigenetics. Epigenetics, where genes meet real life. Epigenetics is the science that broke the old nature versus nurture binary and replaced it with something far more interesting. Your DNA sequence, the actual ATCG code in your cells, is largely fixed from birth. But whether specific genes are expressed, how loudly, and in response to what triggers is controlled by a layer of chemical marks on top of the DNA. These marks, methylation patterns, histone modifications, non-coding RNA signals, can be turned on or off by your environment, your diet, your stress, your sleep, and your behavior. And some of them can be inherited. This is not metaphor. This is molecular biology with decades of evidence. The Dutch hunger winter study is the most cited example. Children conceived during the Dutch famine of 1944–45, when their mothers were severely food deprived, were born with epigenetic programming that anticipated scarcity, more efficient fat storage, different metabolic set points, altered insulin responses. 60 years later, these individuals showed higher rates of obesity, metabolic syndrome, and cardiovascular disease. Their DNA sequence was normal. Their epigenetic programming was shifted by an event that happened before they were born. The implication: you may be carrying epigenetic programming from your parents' or grandparents' environment. their chronic stress, their nutritional deficiencies, their relationship with food scarcity or abundance. This is not your fault. It is also not immovable. The remarkable thing about epigenetic marks is that many of them are reversible. Consistent exercise, dietary patterns rich in methyl-donating nutrients, folate, B12, choline, same, stress reduction practices, and adequate sleep all have documented effects on epigenetic expression. You cannot rewrite your DNA. You can, with time and consistency, shift which genes are expressed and how. This is where your habits change your genes stops being a motivational poster and becomes actual molecular biology. The specific genes that actually matter for weight. Genetic testing for health has exploded in the last few years. 23andMe, Ancestry, and a growing number of clinical genomics platforms now give consumers access to their SNPs, single nucleotide polymorphisms, specific genetic variants that influence metabolism, appetite, and body composition. Here are the ones with the most robust evidence. FTO gene, the fat mass and obesity associated gene. The most studied obesity-related gene. Variants in FTO affect appetite regulation, specifically by influencing levels of ghrelin, hunger hormone, and the ability to sense satiety after eating. People carrying the risk variant of FTO, approximately 16% of the population carries 2 copies, eat an average of 100-200 more calories per day than non-carriers, not because of poor choices, but because their satiety signaling is genuinely blunted. The important finding, in people with FTO risk variants who exercise regularly, the genetic effect on BMI is significantly reduced, by up to 30% in some studies. The gene loads the gun. Physical activity can substantially unload it. MC4R gene. The melanocortin 4 receptor gene regulates energy balance in the hypothalamus. MC4R variants are the most common cause of monogenic, single-gene obesity. They impair the brain's ability to register fullness and regulate energy expenditure. About 5% of people with severe obesity carry MC4R variants. For these individuals, standard diet advice is particularly inadequate. Their neurology is working against them in ways that willpower cannot simply override. PPARG gene influences how your body handles fat storage and insulin sensitivity. The risk variant of PPARG is associated with greater tendency toward fat storage, particularly in response to high saturated fat intake. Carriers respond better to diets lower in saturated fat and higher in monounsaturated fats, Mediterranean-style patterns. The gene doesn't cause obesity, it shifts the optimal diet composition for metabolic health. ADRB2 and ADRB3, beta-adrenergic receptor genes. These genes affect how well your fat cells respond to adrenaline signaling, essentially, how readily your body releases stored fat for burning during exercise and caloric deficit. Variants in these genes are associated with slower fat mobilization, particularly from visceral and subcutaneous fat. People with these variants often see slower initial weight loss results despite the same effort, and respond better to specific types of training, more moderate intensity, sustained cardio rather than very high-intensity short bursts. Clock and PER genes, circadian rhythm genes. Emerging and genuinely fascinating. Your circadian biology, the timing system that controls when your body does what, has a meaningful genetic component. Variants in clock and PER genes affect chronotype, whether you're a natural early riser or night owl, meal timing sensitivity, and how significantly disrupted circadian rhythms affect your metabolism. People with certain clock variants are more metabolically vulnerable to irregular eating schedules, late-night eating, and shift work. Same food eaten at different times produces different metabolic outcomes, and genetic variants make some people far more sensitive to this timing effect than others. The microbiome, the third player nobody talks about enough. Here's the variable that sits between genetics and habits and doesn't fit neatly into either category: your gut microbiome. Your intestinal microbiome, the roughly 38 trillion microorganisms living in your digestive tract, influences your weight in ways that are now well established in the research literature and were essentially unknown 20 years ago. The landmark study, when gut bacteria from obese mice were transplanted into lean, germ-free mice, the lean mice gained significant weight, eating the same food as control mice without bacterial transplantation. The bacteria themselves drove the weight gain. Subsequent human research has confirmed microbiome composition differences between lean and obese individuals are measurable, consistent, and causally relevant. How the microbiome affects weight. Energy extraction efficiency. Different bacterial species extract different amounts of energy from the same food. A microbiome dominated by firmicutes associated with obesity extracts more calories from food than one dominated by bacteroidetes. Two people eating identical diets can absorb genuinely different numbers of calories based on their microbial composition. Short-chain fatty acid production. Beneficial bacteria ferment dietary fiber into short-chain fatty acids, butyrate, propionate, acetate that signal satiety, reduce inflammation, improve insulin sensitivity, and directly fuel the cells lining your colon. A fiber-poor microbiome produces less of these, worse hunger regulation, more inflammation, worse metabolic outcomes. GLP-1 and PYY regulation. Your gut bacteria influence the production of satiety hormones including GLP-1, yes, the same mechanism targeted by semaglutide Ozempic/Wegovy. A diverse, fiber-fed microbiome produces more endogenous GLP-1. This is, in part, why high-fiber diets reduce hunger beyond simple caloric mechanisms. The genetics connection, your microbiome composition is approximately 30–40% heritable, partially set by the bacteria you were colonized with at birth and in early childhood, influenced by whether you were breastfed, antibiotic exposure in early life, and genetics that affect gut environment. But it is also highly responsive to diet. Fiber diversity and fermented food intake can measurably shift microbiome composition within weeks. This is a modifiable variable with genetic roots. Exactly the pattern we keep seeing. So what actually works given all of this? Here's where this becomes genuinely useful rather than just fascinating. Step 1. Stop comparing your results to other people's results. Seriously. The person next to you at the gym losing weight faster is not evidence that you're doing something wrong. You have a different genetic set point range, different FTO variant expression, different cortisol response, different microbiome, different thyroid conversion efficiency. Their results are not your benchmark. Your results compared to your own previous baseline are the only meaningful data. Step 2. Work with your chronotype, not against it. If you have a natural night owl chronotype, possibly clock gene related, forcing 5 a.m. workouts may chronically elevate cortisol, disrupt sleep quality, and worsen the metabolic outcomes you're trying to improve. Late morning or afternoon training, aligned with your circadian peak, produces better hormonal response and recovery for people with certain chronotypes. Sleep timing consistency matters as much as sleep duration for metabolic health. Step 3. Eat for your microbiome first, weight second. The research increasingly suggests that the most durable weight management comes from building a diverse, fiber-rich microbiome rather than from restriction. 30 different plant foods per week, the benchmark from the American Gut Project, is associated with dramatically more diverse microbiomes. More diversity means better satiety signaling, better GLP-1 production, better energy regulation. This is not about eating less. It's about feeding the biology that regulates how much you want to eat. Step 4. Resistance training is non-negotiable, especially with genetic risk variants. Across multiple genes, FTO, PPARG, ADRB2, regular physical activity, and resistance training specifically, substantially reduces genetic obesity risk expression. Muscle tissue is metabolically active, improves insulin sensitivity independently of weight loss, and shifts your body composition setpoint over time. If genetics loads the gun, muscle building is one of the most reliable ways to keep the safety on. Step 5. Address epigenetics through the boring stuff. Sleep quality. chronic stress management, consistent meal timing, dietary methyl donors, leafy greens, eggs, legumes. These interventions are not glamorous. They are not a new protocol or a trending supplement. They are the inputs that your epigenetic machinery actually responds to, and their effects on gene expression, documented, measurable, compound over years. The honest summary. Your genes set your weight range, influence your hunger signals, shape your metabolic efficiency, determine how you respond to specific foods and training styles, and affect how severely circadian disruption hits your metabolism. This is real and it matters. Your habits determine where within your genetic range you actually land, whether your epigenetic marks shift toward or away from metabolic health, what your microbiome looks like and how well it regulates hunger, and how strongly your genetic risk variants express. Neither side of this wins the argument. The question was always wrong. The right question is, given my specific biology, which I can now increasingly understand through testing, tracking, and paying attention, what inputs produce the best outcomes for me specifically? Not for the person in the before and after ad. Not for your colleague. Not for anyone whose genes, microbiome, hormonal environment, and epigenetic history are different from yours. For you. We are living in the most exciting moment in the history of human health science. We can sequence genomes. We can analyze microbiomes. We can measure epigenetic marks. We can model circadian biology. We have more mechanistic understanding of what drives weight and metabolism than any previous generation. And the conclusion of all that science is not try harder, it's not eat less, move more. It's your body is a specific, complex, individual system, understand it, then work with it. The people who are going to thrive in the next decade of health are not the most disciplined. They're the most informed about their own biology. You're already ahead. Keep going. Comment below, are you someone who feels like genetics is working against you, or do you think habits have been the bigger driver in your experience? I'm genuinely curious how this lands for people. Like if this reframed something for you. Subscribe because next week we're going into the actual genetic tests worth doing in 2026 and how to interpret them without losing your mind. See you there.